You wouldn't know it, but this is a well-coordinated activity done by professionals. But even these professionals can have accidents. That's why we all have to be aware of what we do when we're working around an airplane. Today's airplanes make wide use of composites in their structure. Some of these areas are the wing-to-body fairing, engine cowls, spoilers, aileron, rudder and elevator, landing gear doors, and other primary and secondary structures.
Composites? What are composites?
Simply put, composites are high-strength fibers in a resin matrix. They can be Kevlar epoxy, like this air conditioning duct, or carbon fiber epoxy, like this spoiler, or maybe fiberglass reinforced plastic, like this floor panel. All of these are composites.
Well, why composites on the airplane?
One big reason is weight reduction. Using composites can reduce the weight of a part by up to 20%. On the Boeing 777, the weight saving because of composites is about equal to the weight of 15 passengers plus baggage. Another reason for using composites is corrosion resistance. Plastic parts don't corrode. That's why we're using composites in the floor beams for the 777. Composites also have a high strength-to-weight ratio for both tension and compression loads. This can be as much as 30% higher than aluminum. We can see this when an aerodynamic surface, such as an aileron, is put under load. As the top surface is loaded, it compresses, and the bottom surface is put under tension. As the loads change, the part is subjected to both pressure and sonic fatigue. Again, advanced composite laminates have fatigue characteristics superior to those of metal. Composite laminates get their superior strength from the light, strong fibers and the way they are built up. If we take a composite laminate apart, we can see how the layers or plies are rotated to improve the structure's resistance to stress from all sides. The plies are held together by an epoxy resin matrix, cured under heat and pressure. This relatively weak matrix and strong but brittle fibers supplied little resistance to surface impact damage. That's why, when there are surface strikes to composites, you should report them and have the damage checked in the structural repair manual. The SRM gives inspection and repair procedures. It also gives limits for allowable damage. So, before assuming what is or is not allowable damage, report it. Let me tell you some stories to show you what I mean. Wednesday. The weather is warm, and it's a good day so far on the flight line. Flight 236, a Boeing 747-400, is being worked for a 3:30 departure for Hawaii. The cleaners had just about finished cleaning the cabin, and the guys from Fly Food Caterers are ready to service the galleys. As the catering truck approaches the airplane, Jack Short gets out to guide it in. As he does, Sam Long, lifetime buddy and fishing partner, comes over to catch up on the latest.
Stop! Get her down! Get her down!
I don't see any damage.
Okay, good. Back it on here.
This accident could have been prevented, but it happened. It should have been reported, but it wasn't. And this is what happened. When the truck hit the fairing, it caused the near side of the fairing to disbond from the core and delaminate the skin. This weakened the structure. As the plane went through many cycles, the fibers broke down and the structure failed. This caused the fairing to come apart. If this had been reported, the fairing could have been repaired at the next day check. Now, a $16,000 fairing has to be replaced. Monday, a typical Monday on the flight line.
Hey, Dan. I dropped a screwdriver on the elevator.
You did what?
Yeah, well, it's not a big dent, but it's a dent.
Well, let's go see what you did.
All right.
You call this damage? I've gotten worse dents in my car in the company parking lot. Let's go down. Look, this dent, no problem. I can see a small dent, but it's not bad. Just forget it. It's not worth the paperwork.
Wrong. Composites aren't metal. What you don't see is the damage on the inside. The surface may seem okay, but the skin is broken and has delaminated. As the plane flies, water will get into the honeycomb core and then freeze, breaking the core. And the cycle goes on and on. You can see how a small dent can become major damage. That small dent could have been repaired for about $100 and 8 hours of labor. But it wasn't. And now the entire elevator will have to be reworked. Reworking the elevator will take 800 hours, plus $10,000 for repair materials and fasteners. In addition, a leased elevator will cost about $12,000 for the 2 weeks it takes to repair the original. Any way you look at it, it's a lot of money. Tuesday. It is warm and sunny. Flight 310 is loading. Gary Lead, baggage handler, was loading freight in the cargo compartment. As he waits for another load, he notices a scratch on the engine cowl.
Hey, Bruce! Come here and look at this! Whoa, how'd you do that? Hey, I didn't do it! I just saw it! Well, we'll have to report that. You remember what Earl said about reporting aircraft damage. Okay, but you do it!
Okay. Good thing this was reported. The SRM said that this damage could be covered with speed tape and repaired later. If it had gone unprotected, it would have grown, and a $100,000 cowl would have to be replaced. Remember, preventative maintenance is also important. So repair edge erosion promptly to prevent delamination. Touch up missing paint to protect composites. Repair oil leaks promptly and remove all oil contamination from composites. Use care when opening or closing doors and access panels. Use care when positioning ground equipment. Hot engine exhaust can damage composites. This completes our stories about composite structures awareness. You probably have many stories of your own, but as you have seen, just being careful is not enough. Know what to do when a problem comes up, who should know about it, and where on the airplane the composites are located. And be aware.